All right, welcome to part 2 of finding critical numbers. So this is a much more complicated function than the last two. I am assuming everybody is a master at taking derivatives. I know that's not necessarily the case for some of you, so keep practicing. But since I'm not focusing on taking derivatives here, I did that all last chapter. I'm using Wolfram Alpha to come up with this derivative. Use the product rule / chain rule. So the important thing here is we're going to find the critical numbers. Critical numbers happen where the derivative, which is right here, equals 0, or where the derivative is undefined. So we have a complicated derivative here, so we're going to find a couple places where it's both 0 and undefined. It's a fraction. So the derivative equals 0 when the top equals 0. I'm going to solve this. So I'm going to factor out negative x and reorder the terms just so they're in more typical order. That would make this positive 3x squared minus 2. Solve it. And now this one, add 2, divide by 3, square root. Don't forget your plus or minus. So far I have 1, 2, 3 possible critical numbers. I say possible because I still have to make sure they're defined in the original function. So now to find out where the function's undefined, we have to figure out where the bottom equals 0. That would make this undefined. Now, the only way a square root equals 0 is if whatever you're taking the square root of, the radicand, is equal to 0. So I can just, instead of using the whole square root, I can say the radicand equals 0. Or, if you're more algebraic, this is fine. To get rid of the radical, just square both sides, and you'll still get this. So I'm going to solve. This says that x squared would equal 1, square root both sides, and I just found 2 more possible critical numbers. So there's a total of 5 possible critical numbers. We have to make sure that they're all defined in the original function. The original function has a square root involved, so it's not defined wherever it's the square root of a negative. So we have to carefully do this. If we plug in 0, we get 0 times the square root of 1, which is fine. So 0 is defined. Here's the hard part. Let's start with negative square root of 2/3. If you plug negative square root of 2/3 into this, will you get a valid answer? Will you get something that's defined? Think about it first. If you can do this mentally, better yet. So hopefully your conclusion was, that was fine. We get an answer. If it wasn't, or you're confused, here is the process. If you plug in x equals negative square root of 2/3, you will get negative square root of 2/3 squared. And again, you can do a lot of this mentally, but if it helps, here's what you're thinking. Negative. So we're going to square root of negative 2/3. You'll get, when you square it, it becomes positive, and the square gets rid of the radical. Now, I don't care what the answer is. All we're checking to see is if we get a valid answer. Is it defined? Well, 1 minus 2/3 is a positive number because 2/3 is less than 1. So this number is defined. That tells me, so negative square root 2/3 is defined, so it is a critical number. Positive will be the same thing. So critical number, plus or minus 1. Be careful here. When you plug plus or minus 1 into this, a common mistake is plugging 1 in here and saying, whoa, it's 0. It's undefined. That's not true. It's only if you're dividing by 0 would it be undefined. So if you plug 1 or negative 1 in here, you're going to get 1 times the square root of 0, which is absolutely fine. It equals 0. It's defined. Therefore, we have 5 critical numbers. That one, that 2, and these 2. The last one I want to do is a trig one. Unfortunate, it's trig. And I'm going to add something. I'm going to say find the critical numbers to this. Actually, no, we're going to skip this one. I'm going to do another video with a different question. So stay tuned.